Students are very good at finding prime factors. The method is simple, and no matter which way and how you choose the factors, you will always end up with the same prime factors. However, when students are asked to find all possible factors of a number and they follow the same method that they use to find prime factors, the answer comes out wrong. And in this video, I'm going to show you why and how we miss out those numbers, and what is the best possible way to find all possible factors of a given number. Take a moment to like this video, share it with your friends, and most importantly, click the subscribe button and the bell icon next to it. When you do that, you will get to know the moment we make a new video for you. Let us know if this video was helpful in your comments below. Let's start with a small number first, 24. And the way we do our prime factors is 24 divided by 2. 2 is a prime number, so we can't divide this any further. 12 can be divided into 3 and 4. 3 is a prime number, so it can't be divided anymore. 4 leads to 2 and 2. They are both prime numbers. So the prime factors from here are going to be 2 and 3. And then on top of that, you have other factors like 12 and 4. Now, if by chance we factorize 24 in a slightly different way, by saying I'll do a factor of 3 first, which is a prime number, and the other factor would be 8. 8 is 4 into 2, and 4 is 2 times 2. So while the prime factors here are still going to be 3 and 2, we have an additional factor 8 that didn't show up in the first method. Now, if I try to do 24 again, but this time not with 3 but with 4, and then the other factor will be 6. 4 will be 2 and 2. 6 will be 3 and 2. And in this case, simply because of the way I have decided to start factoring, I have another new factor, 6, which did not show up in the other two methods. So if I follow this particular way of factoring, then I can definitely find all the prime factors. But if I have to find all the factors, that includes prime factors and non-prime factors, there's a possibility of missing out on some of them, because no matter which one you do, whether this one or this one or this one, there would be certain factors which would not be considered in any of these single ways. So the way to find prime factors is rather simple, and if it's a small number, it's even better. So we do 24, and we start with the number 1, with a factor of 1. And we know if we multiply 1 with 24, we get 24. Then we increase this number to 2. 2 into 12 is 24. Now once I find one factor, I'm not going to think of anything else, right? So I'm going to increase the numbers this way, and as I increase the numbers this way, I see that the numbers are decreasing in this way. So logically there would be a place where this side of the equation this side of the numbers would reach its maximum, and this side of the numbers would reach a minimum, and then it would go all over back again. So let's do the next one, which is 3. I know 3 multiplied by 8 is 24. I take the next number, which is 4. 4 multiplied by 6 is 24. I take the next number, which is 5. 5 is not a factor of 24. I take the next factor 6, and I see I am coming back to 4, which is a number I have already done. It's almost like by the time I hit this number 5, I have come to a point where the left side has reached its maximum and the right hand side starts to increase in this way. Right? So from this, all the factors are all the numbers that I have here and all the numbers that I have here. So I have 1, 2, 3, 4, 6, 8, 12, 24. Now let's check from the examples that I did. I know if I do the prime factor method, I will always come back. I'll always have 1, 2, and 3. From the first example, I have a 4. I have a 12. From the second example, I have a 8. And from the third one, I have a 6. And 24 is definitely one of the factors. So this method seems to take care of all the different possibilities in which 24 can be factorized. That would include prime factors and other factors as well. So to answer the question, find the prime factors and all possible factors of 24. So I know the prime factors would be would be 2 and 3, and all factors will be 1. You can also include 1 here. 1, 2, 3, 4, 6, 8, 12, and 24. Now, does this method work if the number is big, like 180? Let's do and find out. You know, if 24, which is a small number, very small number compared to 180, has got 3 possible ways in which I can factorize, or possibly more, 180 would have a lot more. So the possibility of missing out on all factors if I factorize 180 using any of the prime factorization method, I'd lose out on a lot of factors. So let's do the prime factor and then let's see all the factors. $180. Let's start the factorization. 2 and 90. 2 is a prime factor. I can't divide that anymore. 90 can be divided as 2 and 45. 2 is a prime factor. Can't divide that anymore. 45 I can divide as 5 into 9. 5 is a prime factor. I can't divide that anymore. 9 has 2 factors, 3 and 3. 3 is a prime factor. Can't divide that anymore. So the prime factors from here are 3, 5, 2, and 1. Now, like I said, if 24, I can find prime factors in 3 different ways. 180, the number 180 can be factored in more than that, more than 3 ways. So I'm not even going to take a chance. I'm going to straight to the way I should find all factors. So let's start with the number 1. 1 when multiplied by 180 gives 180. 2 multiplied by 90 gives 180. 3 multiplied by 60 gives 180. 4 multiplied by 45 gives 180. 5 multiplied by 36 gives 180. 6 multiplied by 30 gives 180. Now you see, as this column increases in number, this column sort of decreases. When that happens, we know there would be a place where both these columns would have numbers which are very close to each other, and that's when we stop. But the number is quite large, 180. So how do we know to what range this factor would go to? Now this is where memorizing squares come in very handy. So I know 13 square is 169, and I know 14 square is 196, and 180 lies in between 169 and 196. So as I go on increasing this particular column, I know it'll come out somewhere, stop close to 13 or 14, and this column will probably end somewhere between 13 and 14, around 13 and 14, 15, like that. So I know I have a range to work with, and it's not going to be forever, and that's very important to know. Right, so let's go to the next one. 7 is not a factor. I have nothing here. Let's go to 8. 8 does not have a factor here. Let's go to 9. I've got 20. The next number is 10, will be 18. You see how the difference between this column and this column is slowly decreasing? They're both nearing a number or a small set of numbers. 11, I cannot divide 180 by 11, so it does not have a factor. 12 multiplied by 15 gives 180. 13, being an odd number, cannot be a factor of 180. And I know from this situation that the number will be between, the maximum number can never be more than 14. So this is where I stop. Now, just for the sake of calculation, I know 14 is not a factor of 180, right? Nothing multiplied by 14 can give 180. The next number is 12. 15 multiplied by 12. But I know that I already have 15 and 12 here. So this step is not required anymore. So this gives me all the factors of 180. It's all the numbers on this side and all the numbers on this side. So just to summarize, to find all the factors, we got to break it down into two columns. The first column, we start with 1 and we go number by number. We find for each row, we find what the corresponding factor would be to give me 180. Now the thing to note is the calculation that I did on this side. 180 lies between 13 square and 14 square. It's slightly more than 13 and slightly less than 14. So I know the first column number will be very close to either 13 or 14. That's the range that I'm looking at. And I go on calculating and I go on finding each and every number till I see that the numbers start repeating themselves at here. This is when the number starts repeating itself. Now any number I do more than this will just be these numbers. So I know the next number will be 18 and its factor will be 10. The next number will be 20 and the factor will be 9. It'll just follow the same pattern but in a reverse way. So let's write down the answer. Prime factor of 180 will be 2, 3, and 5. That's 2, 3, and 5. And all factors of 180 will be this huge list. It's 1, 2, 3, 4, 5, 6, 9, 10, 12, 15, 18, 20, 30, 36, 45, 60, 90, and 180. So there you go. This is one of the best possible ways in which you can find all the factors. This is almost a foolproof way. It takes a little bit of time, but having to know things like, how much should you be looking at, or what is the maximum number you should be looking at, that helps. And once you reach the maximum, once you reach that limit, it's only going to fold on itself and move back up to the same number.
Take a moment to like this video, share it with your friends, and most importantly, click the subscribe button and the bell icon next to it. When you do that, you will get to know the moment we make a new video for you. Let us know if this video was helpful in your comments below.